So now that we've been able to understand how to find the delta neighborhood of a point as well as the deleted delta neighborhood of a point, let's move on straight away to find the limit point of an interval or the limit point of a set. So given that S is a subset of R, a point A is said to be a limit point of S if for all delta greater than 0, the delta neighborhood of A, which is given by the interval A minus delta, A plus delta, intersection S, contains infinitely many points. Now what this primarily means is that A is said to be a limit point of S if the intersection of the delta neighborhood of A, which is given by this set, that is A minus delta, A plus delta. So A is said to be a limit point of S if the intersection of A minus delta, A plus delta, and S contains infinitely many points. So at this point, we are going to assume that the set S is given by the open interval AB. Now let's represent this on the number line. So we have this to be the number line. We have the point A and the point B. Now because the interval is open at both ends, we are going to draw an open circle on both A and B. So we have open circles here, and this is the interval AB, and that is the set S. Now for a point A to be a limit point of S, the intersection of the delta neighborhood of A, which is given by the interval A minus delta, A plus delta, and S, should contain infinitely many points. So the first thing we are going to do is to find the delta neighborhood of A. Now to find the delta neighborhood of A, we are going to move some distance along the real line both to the left and right by delta. So we move some distance to the right by delta, and then we have this point to be A plus delta. Now we do same for the left hand side, and then we have A minus delta. Therefore, the delta neighborhood of A is given by the interval A minus delta, A plus delta. So this is the interval given by the delta neighborhood of A, and that is this interval A minus delta, A plus delta. So for A to be a limit point of S, then the intersection of this interval A minus delta, A plus delta, and S should contain infinitely many points. So what do you think will be the region of intersection of the interval A minus delta, A plus delta, and S? Now we have S between A and then B, and then we have A minus delta, A plus delta to be this interval. Therefore, the region of intersection of these two intervals or these two sets is going to be this region. So this is going to be the region of intersection of these two sets, or better still, of these two intervals. Now you realize that between A and then A plus delta, there are infinitely many points. Now since there are infinitely many points between A and then A plus delta, we say that A is a limit point of S. Therefore, A is a limit point A is a limit point of S. So A is a limit point of S simply because the intersection of the delta neighborhood of A, which is given by this interval, and the set S contains infinitely many points, that is between A and then A plus delta. Now the same applies to B. B is said to be a limit point of S because if you should find the delta neighborhood of B, which is given by the interval B minus delta, B plus delta, you realize that the interval B minus delta, B plus delta intersection S contains infinitely many points. Now since we have infinitely many points between B minus delta and B, then we say that B is also a limit point of S. Therefore, B is also a limit point of S. So this is basically a brief introduction to how to find the limit point of an interval, or better still, of a set. Now in the next section, we are going to solve a couple of examples and we are going to dive more deeper into this concept. So let's take our very first example. What is or are the limit points of the interval 0, 1? What is or are the limit points of the interval 0, 1? Now to solve this question, in the previous section, we got to understand that a point A is said to be a limit point of a set if the delta neighborhood of that point A intersection the set in question contains infinitely many points. Now we have the set in question to be the set S, which is given by the open interval 0, 1. Now let's try to represent this on the real number line. So on the real number line, we have point 0 as well as point 1. And because the interval is open at both ends, we are going to represent that with open circles. Now since we have 0 and 1 to be the only end points of this interval, let's investigate whether 0 and 1 are limit points of this set. So for 0 to be a limit point of this set, then the delta neighborhood of 0 intersection S should contain infinitely many points. Now for 1 to also be a limit point of this set, then the delta neighborhood of 1 intersection this set should contain infinitely many points. Now the delta neighborhood of 0 means that we are going to move a distance of delta to both the left and right of 0. So to the right of 0, a distance of delta, we have delta, and then to the left of 0, a distance of delta, we have negative delta. That is the delta neighborhood of 0 is given by the interval. We have A minus delta, A plus delta. Now in place of A, we have 0. So 0 minus delta, that becomes negative delta. And then 0 plus delta, that becomes delta. So that is the open interval, negative delta, delta. So this is the interval given by the delta neighborhood of 0. Now you realize that the intersection of the delta neighborhood of 0 and the set S is going to be this region. Therefore, since there are infinitely many points between 0 and delta, it means that 0 is a limit point of S. 0 is a limit point of S. Now let's also investigate for 1. So the delta neighborhood of 1 is given by the open interval. We are going to have 1 minus delta, 1 plus delta. So this is 1 plus delta, and then this is 1 minus delta. Here also you realize that the intersection of 1 minus delta, 1 plus delta, and S contains infinitely many points. Now since there are infinitely many points between this region, it also means that 1 is a limit point of S. So 1 is also a limit point of S. Now, do you think that there could be some other limit points of S? Now let's try to investigate. Now let's choose any arbitrary value or arbitrary real number, say x, in between 0 and 1. So we say that let x be any arbitrary real number, and for that matter between 0 and 1. Next, let's find the delta neighborhood of x. So the delta neighborhood of x is given by the interval x minus delta, x plus delta. So we have this to be x plus delta, x minus delta. So this is going to be that interval. Now you realize that the intersection of x minus delta, x plus delta, and S contains infinitely many points. Now since this region contains infinitely many points, it means that x is also a limit point of S. Now what this primarily means is that all the elements or all the values between 0 and 1 are all limit points. Therefore, we say that the set of limit points of the interval 0, 1, that is the open interval 0, 1, is the closed interval 0, 1. So what we are actually saying is that all the interior points or all the points in between 0 and 1 are limit points, including 0 and 1 themselves. So the set of all limit points of S, which is given by the open interval 0, 1, is the closed interval 0, 1, that is including 0 and 1 themselves. Now let's move on to the second example. Now to example 2. What is or are the limit points of S, which is equal to a single element 2 union the open interval 5, 7. Now let's try to represent this set on the number line. So we have this to be the point 2, and then since this is a single element, we are going to represent this with a closed circle. Union, we have the interval 5, 7. So this is an open interval. So we represent that with open circles, or better still, hollow circles. So the set S is made up of elements 2 and then elements between the open interval 5 and 7. Now we know that for a point to be a limit point of S, then the delta neighborhood of that point, intersection S, should contain infinitely many points. So like we did in the previous example, let's investigate for 5 and 7. So the delta neighborhood of 5 becomes, on the right hand side we have 5 plus delta, and then on the left hand side we have 5 minus delta. Now also for 7, we are going to have 7 plus delta on the right, and then 7 minus delta on the left. Now if we should find the region of intersection between the interval 5 minus delta, 5 plus delta, and S, you realize that the intersection has got infinitely many points, which means that 5 is a limit point of S. Now the same applies to 7. This is going to be the region of intersection of 7 minus delta, 7 plus delta, and S. So since we have infinitely many points within this region, it means that 7 is also a limit point of S. And for that matter, all the interior points are limit points of S. Therefore, we know that the limit point of S at this stage in our solution is the set of points between 5 and 7, including 5 and 7 and themselves. So it's the set of closed interval 5, 7. Now what about 2? So we can find the delta neighborhood of 2, which is the open interval 2 minus delta, 2 plus delta. Now if we should find the intersection between this open interval 2 minus delta, 2 plus delta, and S, you realize that the only element of S here is 2. Now notice that all these elements here, that is between 2 and 5, are not contained in S. All these elements between 2 and 5 are not contained in S. The only element of S is 2. Notice that since the intersection between 2 minus delta, 2 plus delta, which is this intersection, and S does not contain infinitely many points, it means that 2 cannot be a limit point of S. Now 2 here is called an isolated point of S, and that is what we are going to treat in the next video. So the limit point, therefore, the limit points of S is given by the closed interval 5, 7. Example 3. Find the limit point of S. Now S is an infinite set, so we are going to find the limit point of this infinite set. Now an infinite set may or may not have a limit point. Okay, an infinite set may or may not have a limit point. Now let's investigate whether this infinite set has a limit point or not. Now we said that for a point, say A, to be a limit point of S, then the delta neighborhood of A, intersection S, should contain infinitely many points. So let's draw, or let's represent this set on the number line. So we have this to be the number line, and then we have the set S. So we have our first element to be 1. So we have 1, 2, 3, 4, 5, and then continuous on and on and on. Now since 1, 2, 3, 4, 5 are part of the set, then we are going to represent that, or each of the numbers with closed circles, indicating that they are part of the set. Now let's start off with 1. The delta neighborhood of 1 is given by the interval 1 minus delta, 1 plus delta. So this is the interval given by the delta neighborhood of 1. Now the intersection of the delta neighborhood of 1 and S contains only one element, which is 1. Therefore, since it does not contain infinitely many points, then it means that 1 cannot be a limit point. Now the same applies to 2, to 3, to 4, to 5, and so on and so forth. Therefore, we can conclude that this set has no limit point. This set has no limit point because the delta neighborhood of each of the elements in here, intersection S, gives only a single element. Therefore, since the intersection does not contain infinitely many points, then that element cannot be a limit point of the set. Example 4. Find the limit points of S. Now S contains elements, or S has elements 1 over 2, 1 over 4, 1 over 8. So this set is said to be a finite set. Now in general, a finite set has no limit points. So a finite set in general has no limit point. Therefore, the set S, which is a finite set, has no limit point. Now this is so because for any element that you select, now the delta neighborhood of that element, intersection S, does not contain infinitely many points. It means that that element cannot be a limit point of the set, and this occurs to all the elements in the set. Therefore, the set S, which is a finite set, has no limit point. Now to the last example for this video. Find the limit point or limit points of the set. Now the set S here is an infinite set. So first of all, let's represent this set on the number line. So on the number line, we have the point 1 over 2, we have 2 over 3, 3 over 4, and so on and so forth. Now 1 over 2 is 0.5, 2 over 3 is 0.67, and then 3 over 4 is 0.75. Now you realize that this sequence or this set of numbers is approaching a certain number. Now if it goes on and on, you realize that this set of numbers is approaching 1. Now as this set of numbers approaches 1, then we can have the open interval, which is represented by the delta neighborhood of 1. So that is going to be 1 plus delta, 1 minus delta, such that the intersection of this interval, which is 1 minus delta, 1 plus delta, and the set S will have infinitely many points. So as this set of numbers approaches 1, the delta neighborhood of 1, which is giving us the interval 1 minus delta, 1 plus delta, intersection S, will have infinitely many points. Therefore, we say that the limit point of this set, which is S, is equal to 1. Notice that the limit point of a set may or may not necessarily need to be part of the set. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.